Blow a gap through the Himalayas to let cold air flow in. This is probably the simplest wish lingering in the minds of India's 1.4 billion people right now. In June 2026, India is suffering from sweltering heat that feels like purgatory. Daytime temperatures in New Delhi hit 46 degrees Celsius, with nighttime lows still hovering at 35 degrees Celsius, marking the first round-the-clock heat wave in 14 years. The air is stifling and foul-smelling, and most Indians cannot afford air conditioners. As for the idea of blasting through the mountains, it all depends on whether neighboring countries would consent to it. Today's topic: electricity-free cooling. Data from the International Energy Agency shows that among India's 1.4 billion residents, there are merely 94 million air conditioners, representing a penetration rate of less than 10%. The price of a standard air conditioner equals 8 to 10 months' wages for low-income laborers. Even if someone scrapes together the money to buy one, the monthly electricity bill will place a heavy financial burden on them. Industrial electricity rates in India are far from cheap, and residential tariffs vary drastically across different states. In some regions, tiered pricing schemes can leave air conditioner users in financial ruin by month's end. An even more pressing issue is unstable power supply. Despite India's push for universal electricity access, blackouts are frequent, rendering air conditioners useless. Research estimates that if every household in India were to satisfy their air conditioning demand, the total power consumed solely by residential AC units would exceed Africa's entire current electricity consumption. This traps the 1.4 billion population in a vicious paradox. The hotter it gets, the more people need air conditioning, the more AC units run, the more strained the power grid becomes. The more strained the grid, the more frequent power outages, the more power cuts there are, the hotter it grows. So what is the solution? Flee. In the summer of 2026, Indians cast their votes with their feet. Many Indians travel to the Bund in Shanghai to escape the heat. Far more opt to emigrate to escape their homeland. Related statistics show that 35.4 million Indians live overseas across 207 territories. With 2.5 million new immigrants every year, in 2025, people of Indian descent became Australia's largest immigrant group, outnumbering those of British origin. 70% of US H-1B visa holders are Indian nationals. Many senior executives at tech firms in Silicon Valley are of Indian descent. Emigration has effectively become a national export for India, with extreme weather acting as its biggest driving force. Yet, it is impossible for all 1.4 billion people to leave the country. Therefore, the crux of the problem lies in finding a cooling method that requires no electricity, costs little, and can be rolled out on a massive scale. Such a solution exists. Its inspiration comes from a tiny ant. The Saharan silver ant lives on the blistering surface of the Sahara Desert and can forage outdoors even at temperatures of 70 degrees Celsius. Its secret lies in the special triangular-shaped hairs covering its body. These hairs reflect most visible light, while radiating the ant's body heat via mid-infrared wavelengths straight through the atmosphere into deep space, where temperatures drop to just 3 Kelvin. Put simply, the ant comes equipped with a natural reflective suit that casts excess heat out into the cosmos. Scientists copied this natural design to develop passive radiative cooling technology. Its principle sounds almost sci-fi. Coat the surface of an object with a special material that performs two key functions at once. First, it reflects over 95% of sunlight, blocking heat from seeping in. Second, it emits heat as infrared radiation through the atmospheric transparency window of 813 micrometers into outer space. It dissipates out to space to create a cooling effect, as outer space sits at roughly minus 270 degrees Celsius. This technology requires no electricity, compressors, or refrigerants. Cooling takes effect once the coating is applied. Electricity-free cooling coatings inspired by the Saharan silver ant are already commercially available. Products from Hong Kong's SkyCool Technologies can lower rooftop temperatures by 20 degrees Celsius and shipping container temperatures by 10 degrees Celsius. Cooling thin films developed by Tsinghua University research teams are entering mass production. A 2025 KPMG report names it an innovative zero-energy cooling solution. Imagine the tin and brick shanties in India's slums coated with this electricity-free cooling paint, bringing indoor temperatures down by 5 to 10 degrees Celsius. No grid upgrades, expensive equipment purchases, or lengthy infrastructure construction are required. It may well be the cheapest, fastest, and most grid-independent cooling option available. Amid global warming, conventional cooling appliances are limited by barriers of electricity access and affordability. Radiative cooling only needs rooftop coverage to deliver cooling. If technology exists to narrow the gap between rich and poor, this innovation holds far greater value than high-end consumer electronics. Tiny ants survive the hottest midday hours of the Sahara, and perhaps 1.4 billion people can too.